So, have you ever been on a website? You click a button for what you know is a big job, maybe sending out a whole bunch of emails or, I don't know, generating some huge report.
Oh, yeah.
And then nothing happens.
Yeah.
Or you get that little spinner icon, just going round and round forever, it seems.
It's super frustrating. You're just left hanging.
Exactly. Wondering, is it working?
Yeah.
That's still like, crash. Am I just stuck here?
That feeling, that uncertainty, it's actually a really common challenge in web applications. And, well, that's exactly what we're diving into today.
Okay.
These long-running processes. Many web tasks can simply take, well, too long to finish in one go.
But like sending thousands of emails, you meant?
Precisely. Or processing a massive file upload, or running complex calculations. If they're not handled the right way, they often just time out. Yeah, the connection breaks or the server gives up. Yeah. And it leaves both the application and you, the user, completely in the dark.
And that's just, well, it's a recipe for a really bad user experience, isn't it? So our mission for this deep dive then is to unpack a really kind of clever and robust way to manage these long-running processes. We're going to be exploring insights from a pretty detailed guide. It was published on the Xlinesoft blog back on August 28, 2023.
Right, I remember that one. It uses PHPRunner and ASP.NET for its examples, but the idea behind it is much broader.
Exactly. The core principles, they're basically universal. So hopefully by the end, you'll have a much clearer picture of what's actually happening behind the scenes when you see like a progress bar ticking along nicely.
And why it's so important for making things reliable and, just feel smooth when you're using a site.
Yeah. So where does this problem really come from, these timeouts?
Well, it boils down to the basic limits of how the web works, traditionally anyway. When your browser asks a server to do something, it kind of expects an answer pretty quickly.
Like a conversation. You ask, you get an answer.
Exactly. And if that answer doesn't come back within a certain time, maybe 30 seconds, maybe a minute, it varies. The connection might just drop.
Okay.
Or the server itself might say, hey, this is taking way too long, and just stop the process to save resources.
So trying to process, I don't know, 1 million emails with just one click.
Yeah, that's almost guaranteed to fail in a standard setup. It'll hit those limits.
Right. And that's where the user frustration really kicks in. We don't know if it's actually, humming along fine in the background.
Or if it's completely stuck.
Or if it finished ages ago and just forgot to tell us.
Exactly. The article we're looking at specifically calls out batch sending email notifications as a really common example.
But it's not just email, right? It could be anything that takes time.
Anything resource intensive, yeah. Report generation, data analysis, image processing.
So what's the clever solution then? How do we get around this timeout problem?
Well, the core insight, and it's really elegant, is not to try and force the server to do one massive task super quickly. That's often impossible.
Okay.
Instead, you break that big task down into smaller, much more manageable batches.
Batches, like little chunks of work.
Precisely. And what the approach in this article highlights is how you use technologies on the browser-side JavaScript and something called AJAX to manage this.
AJAX, I've heard of that.
Yeah, asynchronous JavaScript and XML. It's key here. Instead of one huge long server request that makes your browser wait.
And probably times out.
Right. You use JavaScript to kick off the process, and then you send these small batches of work to the server, one after the other, using AJAX requests.
Okay, hold on. So it's not one big ask, it's lots of little asks.
Exactly. Like setting up a little assembly line between your browser and the server.
And that word asynchronous in AJAX. That's important, isn't it?
Crucial. It means your browser can send off one of these little requests to the server and not lock up waiting for the answer. It can stay responsive, update the screen.
That's how they show the progress bar updating.
You got it. While one batch is being processed by the server, the browser isn't frozen. It can receive updates from the server about previous batches or just let you carry on interacting with other parts of the page.
So each time a small batch, say 10 emails, get sent to the server.
The server processes just those 10 quickly, sends back a little, okay, done with those 10, here's the status message.
And the browser gets that message, updates the progress display, 10 of 1,000 sent, and then sends the next batch.
That's the core loop. It gives you two huge benefits. Reliability, because each small request is fast and unlikely to time out.
Makes sense.
And you get that continuous real-time feedback for the user. They see progress happening, which is massively better than just staring at a frozen screen or a never-ending spinner.
That really does sound like a beautiful solution, as one commenter on the article apparently noted. Especially for things where you want that immediate feedback, like sending those emails or generating reports someone's waiting for right now.
Definitely.
But what about tasks that might take like hours or even days, where the user is definitely going to close their browser window? Does this AJAX batching thing still work?
That's a really good question. It highlights the sort of trade-offs. This AJAX-driven incremental pattern is fantastic when you want that real-time feedback when the user is actively waiting or monitoring on the page.
Okay.
For those truly long-running, maybe offline tasks, think massive data conversions, complex scientific simulations where the user will navigate away or close the browser. You typically need something more robust running entirely on the server side.
Like what?
Often you'd use background job queues, things like RabbitMQ or Kafka or Celery. You basically put a job request onto a queue, and separate worker processes pick it up and run it independently of the web request or the user's browser session.
So that's a whole different level of asynchronous processing.
It is. It guarantees the job gets done eventually, even if the web server restarts or the user logs off. But for the majority of long tasks initiated by a user within a web app where they expect some feedback fairly soon, this AJAX batching pattern is incredibly effective and widely used.
That distinction is really helpful, thanks. So, okay, let's walk through the steps from the Xlinesoft article. How does this actually get built? How did the user even start this whole thing?
Right. It starts naturally with the user interface. The example they use is pretty straightforward. A simple send emails button.
And where is this button?
They place it on a customer's list page, which makes sense, right? You're looking at a list of your customers, maybe you filtered them, and now you want to perform an action on them, like sending them an email.
Okay, makes sense. So you click the button, and what happens then? It can't just be a standard form submission, can it?
Yeah.
Because that would likely time out.
Exactly. No standard submission. When you click that button, some JavaScript code runs. This is often called a client-side event handler. It runs right there in your browser.
And what does this JavaScript do?
First, it figures out how many items, in this case, emails, it wants to process in each batch. The article uses a variable, mail per step, and sets it to 10.
So it decides, okay, we'll do this in chunks of 10, not the whole list at once.
Precisely. Then, and this is crucial for the user experience, it immediately creates and shows a little pop-up window.
The progress window.
Yep. The article uses a function like runner.display pop-up. This pop-up is designed to show the status updates. Things like sent mails, X of Y, successfully mailed, Z, errors.E. That's your feedback mechanism right there.
Okay, so the pop-up appears. What next?
As soon as that pop-up is visible, the JavaScript code calls another JavaScript function. And this function is designed to be recursive.
Recursive, meaning it calls itself.
Exactly. Let's call this function AJAX step, like in the article, or maybe process batch. The point is, it's designed to call itself repeatedly to process each batch in sequence.
Okay, a self-calling function, what does it do on its first call?
On its first call, AJAX step immediately makes an AJAX request to the server. The article shows using .jgat, which is common with the jQuery library.
And what does it send in that request?
It sends the current step number, starting at step 0 or 1, and that mail per step value, which is 10 in their example. Basically telling the server, hey, process the first batch of 10 records.
Got it. So it sends the request off, then what?
Then it waits for the server to respond. The server does its work for that batch, we'll get to that bit in a second, and sends back a response containing the status for that specific batch.
Like how many it actually processed, how many succeeded, how many failed.
Exactly. The AJAX step function receives this response and uses the data inside it to update the text inside that progress pop-up window we mentioned earlier. So the user sees sent mails, 10 of Y, mailed, 9 errors, 1, for example.
Real-time updates. Okay, so it updated the pop-up. What makes it recursive? How does it process the next batch?
This is the clever part. After updating the pop-up, the function checks the response from the server. Specifically, it looks at how many records were actually processed in that last batch, total sent in the article's example. If the number processed, total sent, is less than the number it requested, mail per step, which was 10, what does that usually mean?
It means there weren't 10 records left to process. It must have hit the end of the list.
Precisely. It means we're done, or at least done with this pass. So in that case, the recursion stops. The function doesn't call itself again. Instead, it might show a final done message the article mentions using swal done, which is a common way to show nice alerts.
Okay, so that's the exit condition for the loop. But what if total sent was 10? Meaning there might be more records.
Right. If total sent equals mail per step, it assumes there's more work to do. So it increments the step counter. U step 1 becomes step 2, and then it calls AJAX step again, passing the new step number.
And the whole process repeats. Request batch 2, wait, update pop-up, check if done, if not, request batch 3.
Exactly. It's a continuous loop driven by the client-side JavaScript, making small, manageable requests to the server until all the work is completed.
That's really elegant. But hang on. For the pop-up to show sent mails, X of Y, that Y part, the total number of customers or emails, how does the JavaScript in the browser know the grand total before it even starts the first batch?
Excellent question. That's the second piece of this puzzle. That information needs to come from the server before the user even clicks the Send Emails button.
How does that work?
Typically, when the list page itself is being prepared on the server before it's sent to your browser, the server does a quick calculation.
Like before the HTML is generated?
Exactly. Often in an event like before display or similar, depending on the framework. The server runs a very simple database query like select count from customers where the emails are stored.
Just to get the total number?
Just the total count. Let's say it finds 153 customers. The server then needs to pass this number 153 to the client-side JavaScript environment.
How does it do that?
The article mentions using a specific function, PageObjectSetProxyValue in PHP, or PageObject.setProxyValue in C#. These are framework-specific ways, but the general idea is common. Embedding that server-calculated value into the page's JavaScript context.
So when the page loads, the JavaScript already has a variable, say, recount, set to 153.
Precisely. So when the AJAX step function runs later and needs to update the pop-up text, sent mails, X of Y, it already knows the value for Y.
Okay, that closes that loop. So client side knows the total, creates a pop-up, recursively calls an AJAX function in batches, server side, provided the total count initially. Now, what happens on the server when it receives one of those AJAX step requests for a specific batch? That's the heavy lifting part, right?
That is indeed where the actual work for each batch gets done. On the server, there's code set up to listen for these specific AJAX requests.
How does it know it's one of these requests and not something else?
The client-side AJAX call usually includes a specific parameter, like AJAX mail1 or something similar, as mentioned in the source. The server-side code checks for the presence of this parameter. If it's there, it knows, this is a request to process an email batch.
Right, a signal.
Exactly. When it receives such a request, the server first sets up a little structure, like an array or an object, to hold the results for this specific batch. It needs to track things like total sent, how many it processed in this batch, errors, and mailed, how many succeeded.
Okay, initializes its counters for the batch.
Then it reads the data sent from the client, the mail per step, which is 10, and the current AJAX step number.
So it knows which batch it's supposed to process.
Correct. And using the step number and the batch size, it calculates the starting point. For step 1, the first batch, it starts at record 0. For step 2, it was start at record 10, and so on.
Right, simple maths.
Then comes the crucial database query for this batch. It constructs in SQL query using a limit clause, or top offset fetch, depending on the database system.
Limit clause?
Yeah.
That's important. Why?
Because it tells the database, don't give me all customers, just give me, say, 10 customers, starting from record number 20. For example, select from customers limit 20, 10.
So the server only ever pulls a small, manageable chunk of data from the database for each request.
Exactly. This is absolutely key to keeping the server-side processing fast and efficient for each batch. It avoids loading thousands of records into memory at once.
That makes total sense. It avoids the very timeout problem we started with.
Precisely. The server gets just the 10 records, or however many are in the batch. It then loops through only those records.
And inside the loop.
Inside the loop, it performs the actual task for each record. In this example, it would call the email sending function. Runner mail is used in the article's pseudocode for each of the 10 customers' email addresses.
And it checks if the email sending worked.
Yes. Based on whether the runner mail function returns success or failure, it increments either the mailed counter or the errors counter for that batch. And it always increments the total sent counter for each record it attempts in the batch.
So it processes its 10 records, tallying the results. What then?
Once it's looped through all the records for that batch, it has the final counts, total sent, mailed, errors for that specific batch. It packages these counts up, usually into a JSON format. JSON is just a standard text-based way to represent data that JavaScript understands easily. So it creates a JSON string like total sent 10, mailed, 9, errors, 1.
Okay.
And finally, the server sends this JSON string back as the response to the AJAX request that came from the browser.
And the server's job for that request is done.
Pretty much. The article mentions echoing the JSON and then exiting or ending the response. It's finished its small task and sent the results back, ready for the next AJAX step request from the client, if there is one.
Wow, okay. When you break it down like that, it really clicks. It's this constant back and forth, this little conversation between the browser and the server, processing things chunk by chunk.
It is, and you can see how each part plays a critical role. The client initiating, managing the loop, and showing progress. The server doing the actual work efficiently in small batches.
This deep dive, it really does feel like it's about more than just sending emails, doesn't it? It feels like a fundamental pattern.
It absolutely is. This isn't some niche trick. It's a core architectural pattern for building robust, user-friendly web applications that have to deal with tasks that, well, take time.
It really highlights how using client-side smarts, the JavaScript, the AJAX, combined with that careful server-side batching, lets you work around those inherent web limitations, those timeouts.
And the payoff is huge. You get reliability and you dramatically improve the user experience by giving them that transparency, that feedback. No more guessing if it's crashed.
Yeah, turning that frustrating wait into something informative. It's a core concept, really, whether you're building a new app today or just trying to understand how the complex websites you already use actually work.
Definitely. When developers implement this kind of pattern, they're building a more resilient and, frankly, more pleasant web experience for everyone.
So we've seen how breaking down that big, scary task into these smaller, manageable chunks and adding that real-time chat between the browser and server, it just transforms the whole experience, makes it reliable, makes it informative.
It's that intricate dance, isn't it? JavaScript, AJAX, server-side logic, all working together.
It really is. So the next time you're on a website and you see one of those progress bars smoothly ticking along, maybe take a second to appreciate the cleverness happening behind the scenes. All that work just to keep you in the loop.
It makes you wonder.
Yeah. What other everyday web interactions do you think might be using this same fundamental pattern? This idea of batch processing and real-time updates hidden just beneath the surface.